Okay, so last week we talked about inheritance and pointers and how if we don't use inheritance with pointers, we can come into this object slicing issue where we lose functionality, mainly data members that exist in the derived class that are not in the base class. So we also talked about overriding class functions and inheritance, and how we have to be careful and know that you can call base class constructors from the parent class, right? And we did that, and you'll need to know that for tic-tac-toe also. So what was it? Inheritance constructors. Inheritance a protected access, which makes data or functions available in a derived class. And class function overriding, the keyword override, and final, which can help us maintain the integrity of our code. And then we went and did some examples that covered these topics. We also covered file input and output and how files work like cout and cin, or the ostream istream functionality, where we can include the f stream and we can talk to the hard drive, read data from the hard drive, send data to the hard drive. And then we go lower level, we can read data into memory, into our streams, and into our source code. So we also covered an example where we created a vector of temperature objects, sent that to data hard drive, and then we did the opposite. We read those records, created a temperature object, added the temperature object to a vector, and we repeated that for every record, and then we recreated the vector we had written out to file by reading it in from file. Okay, so you'll be doing the same thing for the tic-tac-toe application. So this week we will cover dynamic memory allocation. So we'll talk about memory leaks briefly, but we'll focus on creating dynamic memory with objects, with integers, and the importance of structuring code correctly to prevent memory leaks, or have the situation that's called a dangling pointer, where two pointers point to memory, but one pointer deletes the memory and then the other pointer is still pointing to memory, thus creating a pointer that's pointing to invalid data or to trash. So we want to prevent those situations, and then we will eventually get into creating our vector class, hopefully this week. But before we do that, so why do we do the vector class? That focuses on teaching us how to work with dynamic memory in classes. But there's also free functions. So we'll start out with how to best manage memory that's created using the procedural programming. It's a little bit more difficult, but we'll see that with the help of smart pointers, we can get pretty good results and eventually have a high probability of preventing memory leaks and dangling pointers. Okay, so from now on, it's memory management deep dive. Very important to understand these last few lectures. They will help you for data structure, so do not take this last few weeks lightly. Okay, I think that's it. Where do you find this information? Chapters 10, chapter 10, the second half, you'll find the dynamic memory piece. The author doesn't go deep into it, but we will. Okay, but still reading those chapters will help you. Okay, get ready. Also, if you didn't read chapter 8 for arrays last week, give it a glance and it'll give you a good idea of what I'm covering when I'm talking about creating the legacy list in C++, which were created using arrays. Okay, so let me see what else. I think that's it. So I will see you in class. Thank you.